There are some situations that involve two objects or items that occur with two different regularities or at two different intervals. Besides using brute force calculations to find out when they occur at the same time, we can use the least common multiple or LCM method to do it a bit more easily. So if you're unsure what I was talking about with two different regularities, it just means something like this. A comet orbits the sun every 75 years. Another smaller comet orbits the sun every 50 years. If both comets are at their closest point to Earth this year, when will they be closest together again? So just knowing those facts and nothing else, we can see that one occurs every 75 years and another occurs every 50 years. So we can just use those facts to answer the question. So first off, I'm going to again use the LCM method. So I got 75. And the LCM method just means taking numbers and breaking it down to their prime factors. So 75 is just 5 times 5 times 3, which is just 3 times 5 squared. And then we got 50, which is just 5 times 5 times 2. So 5 times 2 squared. So if I were to find the LCM, first off, I see that there's a 1, 2, and 1, 3. And if you're unfamiliar with the LCM method, quick overview is when you break it down to our prime factors, you want the greatest amount of the prime numbers in your LCM. So the greatest amount of 2's is 1, so we're going to have a 2. The greatest amount of 3's is 1, so we're going to have a 3. And the greatest amount of 5's is 2 5's. There's 2 up top and 2 in the bottom, so we're going to have a 5 squared. So if I multiply those all together, I'm going to end up with 150. And since we're talking about years, I'm going to say 150 years. So the LCM is 150. When will they be closest together again? In 150 years, they will be closest again. There you go. That's how you do it. LCM method. Very easy. Let's look at another example, just a slight twist to it. Not much of a twist, just a slight twist. Two elevators in a building run on different cycles. Elevator A returns to the lobby every 25 minutes, and elevator B returns every 30 minutes. If both elevators are in the lobby at 8 a.m., when will they be both in the lobby at the same time again? So I'm going to take my two numbers again, 25 and 30, and find my prime factors for them. So 25 is easy, 5 squared. 30 is not too bad. That's just 5 times 6, but 6 can be broken down, so we can say 3 times 2. So put them in order, 2 times 3 times 5. So if I find my LCM, I can see that I have 1, 2 here and no 2's there, so I want the greatest amount, so it's a 2. I have 1, 3, no 3, so we're going to need a 3. 1, 5, 2, 5, so I'm going to need 2 5's, the greatest amount. And when I multiply those together, I am again going to get 150. And since the numbers are in minutes, so I'm going to say 150 minutes. But again, I'm asked the question, if both elevators are in the lobby at 8 a.m., when will they be both in the lobby again? So I'm going to need to convert this to hours. So I'm going to divide this by 60. And when I do that, I'm going to end up with 2.5 or 2.5 hours. So I'm going to add 2.5 hours to 8. That's easy. That's going to make it 10:30. So when will they be in the same lobby again? Both will be in the lobby at the same time. At 10:30 a.m. There you go. So same thing we did before, just again, that slight twist just to, add a little twist to it, just something more interesting. Last one. At a brand new theater, the theater lights blink quickly every 45 minutes to test them. At the same theater, a cleaning robot activates every 75 minutes to clean the lobby. If both start at the same time at 12 p.m., when will they both start again at the same time? So we're going to jump in there and we're going to do 45 minutes, find its prime factors, which is going to be 3 times 3 times 5, which is just going to be 3 squared times 5. Then we're going to do 75, and that's going to be, again, 5 times 5 times 3, which is just going to be 3 times 5 squared. Find my LCM. So this one has 2 3s, this one has 1 3. I want the greatest amount, so 3 squared. This one has 1 5, this has 2 5, so I want the greatest amount, so 5 squared. And when I do that, I'm going to end up getting 225 minutes. But again, I'm like the previous question, this is in minutes, but I'm going to try to find some specific time. So I'm going to divide this by 60 to know how many hours have passed by. And it's going to end up being 3.75 hours. And if you're unfamiliar with 3/4 of an hour, that would just be 45 minutes. So I'm going to take my 3.75 and add it to 12 p.m. and I'm going to end up getting 3:45. So when will they both start again at the same time? Both will start again at the same time. Yeah, I kind of butchered that. Time at 3:45 p.m. Again, you could use brute force and figure it out. Sometimes it's pretty easy, straightforward to see what it is. Other times it might be a little bit easier to use the LCM method. I recommend the LCM method just because it's straightforward and to the point.